In particle theory, the Skyrmion is a hypothetical particle related originally to baryons. It was described by Tony Skyrme and consists of a quantum superposition of baryons and resonance states. It could be predicted from some nuclear matter properties. Skyrmions as topological objects are important in solid-state physics, especially in the emerging technology of spintronics. A two-dimensional magnetic Skyrmion, as a topological object, is formed, e.g., from a 3D effective spin hedgehog, by a stereographic projection, whereby the positive north pole spin is mapped onto a far-off edge circle of a 2D disk, while the negative south pole spin is mapped onto the center of the disk. Mathematical definition. In field theory, Skyrmions are homotopically non-trivial classical solutions of a nonlinear sigma model with a non-trivial target manifold topology, hence, they are topological solitons. An example occurs in chiral models of mesons, where the target manifold is a homogeneous space of the structure group where SUL and SU are the left and right parts of the SU matrix, and SUdiag is the diagonal subgroup. If spacetime has the topology S3 times R, then classical configurations can be classified by an integral winding number because the third homotopy group is equivalent to the ring of integers, with the congruence sign referring to homeomorphism. A topological term can be added to the chiral Lagrangian, whose integral depends only upon the homotopy class. This results in superselection sectors in the quantized model. A Skyrmion can be approximated by a soliton of the sign-Gordon equation, after quantization by the Bethe-Ansatz or otherwise. It turns into a fermion interacting according to the massive Turing model. Skyrmions have been reported, but not conclusively proven, to be in Bose-Einstein condensates, superconductors, thin magnetic films and in chiral nematic liquid crystals. Magnetic materials, data storage. One particular form of Skyrmions is found in magnetic materials that break the inversion symmetry and where the de Zielowshinsky-Morier interaction plays an important role. They form domains as small as a 1 nanometer. The small size and low energy consumption of magnetic Skyrmions make them a good candidate for future data storage solutions and other spintronics devices. Researchers could read and write Skyrmions using scanning tunneling microscopy. The topological charge, representing the existence and non-existence of Skyrmions, can represent the bit states 1 and 0. Room temperature Skyrmions were reported. Skyrmions operate at magnetic fields that are several orders of magnitude weaker than conventional magnetic devices. In 2015, a practical way to create and access magnetic Skyrmions under ambient room temperature conditions was announced. The device used arrays of magnetized cobalt disks as artificial block Skyrmion lattices atop of thin film of cobalt and palladium. Asymmetric magnetic nanodots were patterned with controlled circularity on an underlayer with perpendicular magnetic anisotropy. Polarity is controlled by a tailored magnetic field sequence and demonstrated in magnetometry measurements. The vortex structure is imprinted into the underlayer's interfacial region via suppressing the PMA by a critical ion irradiation step. The lattices are identified with polarized neutron reflectometry and confirmed by magnetresistance measurements.